So as I mentioned today, I want to talk about bringing in sort of live audio and video into our web pages. And then next week we're going to work on some more stuff with that. But the capabilities for doing that are brought into the browser via as sort of not an extension, but like a recent set of capabilities called WebRTC, which stands for real-time communication. It's, I guess over the last 5 years, it's really become widely supported by the browsers. And the first sort of API that was available in the browsers was called Get User Media. And Get User Media is a JavaScript function that basically allows you to prompt the user to allow access to your camera or your microphone, and maybe down the road other things like screens and stuff like that, and actually get access to that data as a stream of data in JavaScript, and then you can do something with it. So I have a quick little example right here, which I'm just going to copy the code for this. Actually, you know what? You all know Chris Cristobal? Last year in this class, he made an application called Carbon. And what Carbon does is it allows me to take any text file that I'm editing and share it with anybody who's on the same network via a web browser. So you can actually see the live code in the web browser. So I'm going to try this out. And that way we can do live coding, and you all you can either type along with me, or you can have a copy of the code right there, and you can save it and edit it as you would like. Does that sound worth trying? Okay. So I'm going to open up Atom, and I'm going to create a new file, and I'm going to save it on the desktop called getusermedia.html. And then I'm going to take that file and I'm going to drag it into Carbon. And then if you go to this IP address, 10.17.33.238:3333. 3333. Yeah. You should see a copy of this file, and then if I edit this hello world and I save it, do you see the new code? Oh, cool. All right, so let's create just a basic HTML page with our JavaScript and for a place to put our Get User Media experience or experiment. Type equals text JavaScript, and then I'll paste this in, and we'll look at the code. And you can all tell me if this is worthwhile, as having the live code in front of you, sort of something that's useful. So this block of code, the first thing here is I have a variable for video, and it's document.getElementById, and it's the video. So this is actually referencing an HTML element on the page with an ID of the video, right? So the first thing that we need to do in this example is actually to create an HTML video element. Right, so what is that? What should that look like? Video, and then just ID equals the video. And then these tags, by the way, need to have an opening and a closing tag. Right, they shouldn't just be one single tag. They should always have an opening and a closing tag. And then the next thing is we have this object, and right here it's a JSON object, and it's the constraints for the media device that you want access to, right? And there's a whole set of different constraints that you can use. But basically, I'm saying in this example, I don't care about audio. I don't want audio. I do want video. And I don't care which video source it is. So if you're using a phone, right, and you run this on a phone, you have a front-facing camera and a rear-facing camera. So it's just going to choose the default camera. Or if you have a computer with multiple cameras hooked up to it, it's just going to use whatever the first one is, just the default one. If you go back and you look at the documentation for Get User Media, there's actually a bunch of examples of different constraints, right? So the most basic one is something like this. But you can also specify, you know what, I want to use a video source that has this pixel dimension, or you can set a minimum pixel dimension or a maximum pixel dimension. You can choose an ideal, right? So it's going to try to pick the video device that matches your constraints the best. And then you can also choose, if you're using a phone, these different cameras have labels, right? So they have a facing mode, whether it's front-facing or user-facing or environment-facing. So the rear one is environment and the front one is user. So those are pretty useful as you sort of explore more in this space. You can also get a list of all of the devices and let the user choose maybe which device if you'd like. But in any case, let's keep going through this code. So this is the sort of magical function right here. It's Get User Media, and then you pass in the constraints, and you get a callback with a stream from that device. And this is a special kind of callback. It's called a promise, which we're going to get into a little bit more later. But it basically means when the user, it's essentially a fancy callback. When the user says allow, this function right here should run, right? Then this function should run. And if there's an error, there's a catch right here. And this catch is going to catch any error and run the function that you define in here. So this alert is going to happen if there just happens to be an error, or if the user says no, or something like that. So assuming that the user says yes, this function with the stream is going to run. And then there's an attribute for the video object, right, which is on the page, and it's the source object. And you can hand it one of these streams, and it'll actually act like a mirror, basically. So the video that we get from the camera is now going to display on the video tag on the page. And then there's an event. We have a little event listener for loaded metadata. And when the video object sort of gets the metadata, when it gets the information about the size and the frame rate and stuff like that, then it's actually going to start playing that video object. So,
Sean,
yeah.
Is Navigator then referring to the browser type, or what's Navigator?
Yeah, so Navigator is, if we look at the DOM, Navigator is sort of like one of the highest level DOM elements. It's sort of like the browser itself, like the browser software itself. Instead of window would be sort of the stuff that's within. Navigator's like a higher level up. Let's actually confirm that. Where should I search? Navigator, JavaScript API. Navigator interface represents the state and identity of the user agent. And the user agent is, and it's actually under window. Window, not Navigator. Okay, so I was a little wrong. Yeah, does this make any sense? Represents the state and identity of the user agent. Yeah, what is the user agent?
Proxy?
What's that?
Is it a proxy?
No, I mean it's not like a web proxy, but user agent web browser. Oh, yeah. So a user agent is sort of a term of art that's used when describing the software, right? So, for instance, when you go to my page, SVE204, oops, that's annoying, itp.nyu.edu. This right here is a unique string that the browser software sends to the server that identifies the software, right? So this browser, Chrome, whatever version of Chrome this is reporting its user agent as Mozilla 5.0, and then it's giving a whole bunch of more information. It's Chrome 69, right? If I were to open up a different browser and go to the same page, the user agent would be a little bit different, right? So it's still Mozilla 5.0, but it's Gecko Firefox 6.2, right? So user agent is sort of a term of art that the browsers are using for the reference to themselves, if that, or their software.
And can that, so when I'm headless, I can
Yeah, so there's a,
change I can pretend I'm blah blah blah.
yeah, and you can do that, like Safari allows you to do that. In the developer tools for Safari, you can change the user agent.
Can I do that in JavaScript then as well?
I wonder if you can do that in JavaScript. So right here, Safari has this drop down which allows you to pretend it's a different browser, and this is changing that user agent string so that when it reports it to a server, it has a different name. This is sort of like in the weeds, but it used to be more important when you could do less stuff with JavaScript, when the server had to deliver different style pages for Internet Explorer and Safari and Firefox. The user agent was much more important at that time because you would literally have a different page for Safari, a different page for Firefox, a different page for Internet Explorer. Now, because JavaScript is so powerful now, a lot of that stuff happens on the client side. You'll do different things with different browsers on the client side rather than on the server side. But in any case, Navigator is sort of what I described. It's representing the browser software, if that makes sense. At least that's my understanding. Where were we? Oh, code. All right, so let's try to run this. I'm going to run this off of my desktop. I'm just going to go to Chrome, and I'm going to try to open it from my desktop and see if it works. So one thing is, it's just saying file : ///. That's just the protocol we're using is just the file protocol because we're not loading this off of a server, right? So it's called file. Some browsers don't let you load things off the local file system and access the camera. I think they've relaxed that a little bit, so you can actually develop these things without putting it on a server. But let's see if it works. If I click allow, cannot set source object property of null. Any idea why that is? That's the error message that I got. Let's look at the developer console. Nothing good here. It's because we caught that error. Does anybody know why it would say cannot set source object property of null? So it's implying that video is null. Why would video be null? I defined video here. Yeah.
Maybe because it takes a while to load.
Right. So we forgot to do what we always need to do, which is window.add event listener load, and then run a function when that load happens and put all of this code inside of it. And now we're going to wait for the page to load before we try to access the video element. So we'll say allow. Ooh. All right, that's the whole class. I'm going to go like get some drugs and and play with this. By the way, this is the thing, like I started using, I think my grandfather bought like one of the early video cameras. And like I did this for hours when I was a kid. But okay, in any case, you don't have to watch me relive my childhood. One thing I want to point out with this code is that I'm using the keyword let. What's the keyword let? What is let? What's the difference between let and var? Yeah, it's weird. So JavaScript is it's a terrible, terrible language, right? JavaScript is just, it's awful. And the first thing that they did for creating a variable was use the keyword var. So if I have a variable called 1, I'll just say equals 1. And let's say it's inside a function called hello. And then I have let's say I have an if statement here, if true, and then here I say council.log 1. What do you think should happen, right? So I have this var1 inside of this if statement. And if outside of the if statement, I have council log 1. Yeah.
So it won't council log it because var is local to that function?
That's what you would think. But JavaScript is awful. So what var means is that any variable declared with var has scope within the function that it's declared, no matter how far in a block of code it is. Yeah.
Is it also the case that variables, I don't know if it's like similar to other languages now, where like variables you can change, but when you declare something with let, you can't change it
Oh
anymore?
no, you can change.
Okay.
Let you can change. You're thinking of const.
Okay.
Const are variables that you can't change, right? So they're not variable.
Do they have that in JavaScript?
Yes.
Okay.
So this is new in ES6, right? ES6 is the JavaScript version that was released in 2016. By the way, they're now doing yearly releases. So last June was ES8. So just if you wanted to get a curveball every June, you can look at the new specification for JavaScript. This relentless pace, I don't know. But in any case, ES6 was a major. There were major changes in JavaScript. ES7 and ES8 were very minor, so you can just ignore them. But one of the things that ES6 did is they introduced a keyword let, and I'll say 2 equals 2, and I'll say council log 2. This one will give you an error because the variable declared with let has block level scope, so it exists within the block of code that you defined, right? Var has function level scope, so it exists within the function that you define. Let is like every other language, programming language on the planet. Var is JavaScript's like Frankenstein variable. So let is what a lot of people are migrating to. If that makes sense.
So what's an example where I'm trying to put it into context?
what's like why would you choose one over the other? Yeah. Because you can, it's sort of, you can declare a variable like deep in code, and then it's sort of available elsewhere. And if you don't remember like a variable name or where that variable is defined, or you're importing a library, it can pollute your namespace, your variable namespace, and you end up overriding like some variable that's set elsewhere. So it's dangerous because it has like it comes out of where it was defined, right? Like it pops its ugly head elsewhere, and you can end up, like making an error because you used a variable that was declared deep in your code, and you redeclared it, and it has like some completely different value, and things just don't work. Let has less of a danger of that because it's in a block. It's in that block of code. So let is better.
Okay. So like when I did writing code, when I wrote global variables, I can use it.
Yeah, that's great.
Which is fine.
Yeah,
But
so
you
if
can use let again in a specific block of code, and then it's local
right,
to that block of code.
if I did 2 here, global, and maybe I did this, maybe I called this 3. This one is a different variable than this one.
Your
Right.
copies.
They're not, they're completely, they just have the same name.
Two different copies.
Yeah, they're 2 different things altogether.
Oh.
You just can't refer to that one here because you don't have its name available to you. But so in this block of code, 2 equals 3, which is the way the world should be. And then in this outside of that block of code, 2 equals 2, which is the way the boring world. Right? Does that make sense? Okay. So let is a good idea, something to get used to. By the way, the var variable stuff has really hurt me in the past. Like it's made my life hell at times. But okay, so now one thing is if I want to share this with somebody else, I need to put it on a server, right? So just like we have our normal servers, we're gonna have to create a server to serve this file as well. So I actually created a new DigitalOcean instance because my old one was so out of date and it was messing me up. So it's now called liveweb-new.itp.io. And let me make a new folder here. I'll call it Get User Media. And I'll put this Get User Media HTML file into that directory. And now I need to create a server, right? Why don't we copy, well, let's see, do we have a server from last week? No. Do I have a server in the code? I guess I do. So I'm going to go to last week's oh, let's just do this one. I'll download the example from last week and we'll use that server. So week 3 server.js. So I'm going to put that into the same place. And then let's edit it first. So I'll put it on the desktop. And then I will share it via Carbon so you all have access to it while we're working with it. So now in Carbon, you should have 2 tabs up at the top. One for getusermedia.html, one for server. Is that true? All right. So now, let me edit that. Adam sometimes doesn't like me. So here's our server. Now, we need to do a few different things with this server. The first thing we need to do is we need to make it use HTTPS instead of HTTP because we can't access the camera over a regular HTTP connection. And I think I talked about the reason for that 2 weeks ago. But it's basically for your privacy or for the privacy of people accessing a website that either has a camera on it or injecting code to load somebody's camera. But in order to do that, I have some notes. And if you go to this link on our syllabus, HTTPS, it talks a little bit about that. So the first thing is we should actually talk about like how encryption works a little bit. There's actually a pretty good video here.
Ever met could do an amazing trick.
This is sort of how encryption works on the internet in general, and sort of like this, this current state of encryption. It's a really useful video for sort of understanding how and why it works.
Alice and Bob are allowed to communicate over a line which is tapped, so any message they pass will be intercepted by Eve, who is always listening.
Or Sean.
The trick is to agree on a secret numerical key without Eve also obtaining a copy. How is this possible? First, let's explore how this trick is done using colors. So how could Alice and Bob agree on a secret color without Eve finding it out? The trick is based on two facts. One, it's easy to mix two colors together to make a third color. And two, given a mixed color, it's hard to reverse it in order to find the exact original colors. This is the basis for a lock, easy in one direction, hard in the reverse direction. This is known as a one-way function. Now, the solution works as follows. First, they publicly agree on a starting color, say yellow. Next, Alice and Bob both randomly select private colors and mix them into the public yellow in order to disguise their private color. Now, Alice keeps her private color and sends her mixture to Bob, and Bob keeps his private color and sends his mixture to Alice. Now the heart of the trick. Alice and Bob add their private colors to the other person's mixture and arrive at a shared secret color. Notice how Eve is unable to determine this color since she needs one of the private colors to do so. And that is the trick. Now, to do this with numbers, we need a numerical procedure which is easy in one direction.
We're not going to worry about how to do it in numbers, but you get the idea, right? Like, this is how encryption works. So the browser has a key, a private key. The server has a private key. They have a shared key. They do a function to put their private key into that shared key, put that private key into their shared key. They exchange the output of that function, and then they can actually talk in a secure manner, both encrypting the data with the same key, essentially, without anybody else being able to decrypt it easily, right? Given enough computing power, somebody else could decrypt it, like by mathematical means, trying different things over and over and over again. But it would be very computationally expensive and taking a long time. So in order for us to use things like sensitive data, like sensor data from our computer or from our phones, or camera or audio, we actually need to implement that type of encryption. Thankfully, there's a Node library, that allows us to do that very simply. And it's the HTTPS node library, right? And in order to use it, we basically just have to change up how we're doing our HTTP server a little bit to use that library. So the first thing is, instead of requiring HTTP, we're going to require HTTPS. So if we go to our server here, instead of line 1 var HTTP, we'll say var HTTPS equals require HTTPS. The next thing we need to do, let me see if I can go back to that. The next thing we need to do is we need to have something like this. This is a JSON or a JavaScript object called options, and it's reading two files off of the file system. One is a key, which is a private key, and one is a certificate, and the certificate identifies the server. These are the two things that you need from what's called a certificate authority in order to serve HTTPS pages. Now, it's a little bit painful for you all to do this yourselves, right? Like you'd either have to purchase a certificate or you'd have to go through a service like Let's Encrypt. So I've jump-started things a little bit, and the way that I've jump-started them is I had ITP buy a certificate for anything. It's called a wildcard certificate. Anything in the ITP.io space, right? So when you all sent me your net IDs and your IP addresses, I created a domain name record, right? I basically said sve.204.itp.io is going to point to 128.122.151. Blah, 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 86, right? So when a computer does a lookup and it says, hey, what's SVE204, it's going to direct to that. And because it's in the ITP.io domain, it can use the certificate that ITP purchased. And I'm going to just share that certificate with all of you. Now, this sort of, me sharing this private key and certificate sort of defeats the purpose, because now we all have a copy of the private key. It defeats the purpose of HTTPS. So I still wouldn't do anything where you're like really storing sensitive data until you get your own certificate and your own private key. But in order for us to move forward, we can use these keys. So go to, and I'm going to put this in a video that's going to be online, right? And I'm telling you this in class, so it's really not secure. So this has every appearance of being secure, but it's not really secure. But go to https itp.nyu.edu/sv204 live web fall 2008. Did I write it down? Oh yeah, ITP_IO_cert.zip. So this zip file contains mycert.pem and mykey.pem. So these you're going to need to upload to the server in the same place as the server.js file, right? And they need to have the same name as what's being requested here, right? So I'm going to just go ahead and upload those two files, mycert and mykey, to my server. Yeah, it's the live web class syllabus, and then ITP_IO_cert, CERT.zip. So once you do that, then you can add in sort of this options into our server. So I'm gonna add that in. It needs to be below the FS, require FS, because it actually uses the file system. So I'm gonna do it right here. And then the next thing we're gonna do, let's go back to our example here, is we're gonna create the server, but we're gonna pass in the options along with it, right? So instead of HTTP, blah, 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 we have HTTPS create server, and then we tell it what port to listen on. So our code changes a little bit right here. Instead of doing this, we pass in this, and we also are doing that, so we don't have to do that. All right, now, theoretically, our server should be able to be accessed via HTTPS instead of HTTP. And this server also has some Socket.io stuff at the bottom. But let's take this and upload it to my DigitalOcean droplet, and then I'll log into my DigitalOcean droplet. Oops, not cool term. Terminal. SSH root at liveweb-new.itp.io. Get user media. So let's try it. So node server.js. Handle it is not defined. So I must have used a different function name. So let's see. Handle it. Oh, this one is called, instead of handle it, it's called request handler, right? So let me use that instead. Save it. Upload it. Run it. Oh, now we got another error. Cannot find module socket.io. Anybody know what I did wrong? I didn't, yeah. So I have to say npm install socket.io.
Is the HTTPS built-in?
I think it is, yeah. So the HTTPS library, we don't need to install because it's already there. All right, so there we go. So it's running. Server is listening on port 8080. Now if I go, instead of instead of file, I go HTTPS, oops, liveweb-new.itp.io :8080. And what did I call that? Get user media.html. So now it says live web new wants to use your camera. I'm going to say allow. And now I have a server that anybody can go to and do the mirror trick. So that's the first step. Let's take a little break. Anybody that doesn't have their domain name set up, come see me. And we'll get that set up. And then we'll also do something more with this. All right, who doesn't have their domain name set up? Let me stop this video.